one is starting with probability. So we are going to go back to 7th, 8th grade probability. This was a long time ago. And now we're just going to add on to it. So probability is the underlying foundation on which the important methods of inferential statistics are built. Statisticians reject explanations based on very low probabilities, the rare event rule of inferential statistics. So probability, which we call it P, is going to be the likelihood. I don't know how to spell likelihood. Is it I or Y?
Y.
Likelihood? That looks right.
Wait, that doesn't look right. Yeah, I don't know.
I don't know either. Of an event happening. Maybe it is an I. Maybe it's an I. Yeah, it's an I. I just looked it up. Sorry. Likelihood of an event happening. It's expressed as a number between 0 and 1, where 0 is impossible and 1 is certain, 100% chance. So we use percent. So that's why we go from 0 to 1, because it would be a decimal, which converts to a percent. So let's do a little number line here from 0 to 1. So 0 is impossible. And then we would have 0.5, which is kind of, it's neutral, really. It could happen, it could not happen, but it is likely to happen, just not super likely. And then we could go halfway in between there, 0.25. That would be just considered possible. There's a possibility of it, not very high, but there is possibility. And then 0.75 would be considered almost certain that it's going to happen. So it's more than 50% chance of that event occurring. And then 1 is certain. It's absolutely going to happen. So here are 2 examples. So probability, see how they just put P parentheses? Probability of this event happening. So probability Thanksgiving falls on a Wednesday. Impossible. It never happens. Because why? Thanksgiving's always on a Thursday in November. Probability of Thanksgiving falling on a Thursday? Absolutely certain. So that'd be 1. 100% chance. And we need to learn how to interpret those probability values. So kind of looking at this number line will help us determine what those probability values represent. So we'll have examples like rolling a die, answering multiple choice questions, answering a true or false questions. We round probabilities. Either give the exact fraction or round off final decimal result to 3 significant digits. All digits except 0 that are included for proper placement of the decimal point. So whenever we do this, 3 significant digits, all digits except 0 that are included in the placement. So we would want to do 3 significant digits. So the zeros are significant. So we are going to round this to 0.02. Then the next one be 0.33, because 1/3 is 0.3 repeating. Okay, the next one when we divide them, here. 432 divided by 7842. So that'd be 0.055. So that 5 is going to make the 5 prior to that to be a 6. 0.06. So if we were to look at the probability as a percent, this would be a 2% probability. So it'd be a 33% probability. So it'd be a 6% probability. So we can look at probability as either a decimal or as a percent. Anything close to 1 or close to 100% is a high probability. Probability of getting a heads. What is that probability? If you flip a coin, the probability of getting heads would be half, right? Or 0.5. Or we could write it as 50%. Those are 3 ways of writing. Okay, let's look at the different vocabulary words that we have. So event is any collection of results or outcomes of a procedure. So we're going to look at the probability of different events. So notation, we have A, B, and C denotes specific events. A simple event is one that cannot be broken down into simpler components. So a simple event, tossing a coin, rolling a die. Something that's not a simple event would be tossing a coin and rolling a die at the same time, because that's not simple anymore. You have 2 different events occurring that can be broken down into their own event. Sample space is all outcomes. I guess I should put all possible outcomes of an event. Okay, so a woman wants to have 3 babies. What are the possible gender combinations? So what is a simple event? That would just be 1 boy or 1 girl. We're going to break it down into 1 event, so 1 baby. So we could write that our sample space as B or G. If we were to look at this not as a simple event, more as a compound, we could say 2 girls and 1 boy. The sample space is every possible outcome. So we are going to do it in these little braces. So 1 probability would be boy, boy, boy. Woo, 3 boys. Or it could be boy, boy, girl. Boy, girl, boy. Boy, girl, girl. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. Girl, girl, girl. So that's every possible outcome, I believe.
That sounds about right.
Do what?
That sounds about right.
Yeah. My parents had 3 kids. It's girl, boy, girl. I'm the youngest. So this is your sample space. So what's the probability of my parents? What was the probability of my parents having a girl, boy, girl? It was 1 out of how many? 1 out of 8. So the probability of having all girls is also 1 out of 8, which is what y'all have. You would think this probability would be less, right? Less than this one. But the probability of there being 2 girls in a family would be 1, 2, 3. Well, 4 if you count that one, because there's 2 or more. So there's going to be lots of different ways that we're looking at probability when we look at that sample space. Okay, probability of event A occurring. Probability of A found using 3 different approaches. So we're going to do relative probability. So we are going to do conduct a procedure and count how many times A occurs. So this would be when we actually observe something happening. So you could count how many red cars pass you. And all you're doing is standing out there and observing and counting how many times a red car passes you. But you also have to count how many times a car passes you total. So you would do it as a fraction, number of times A occurs, over total number of procedures / observations. So let's say I see 5 red cars pass by over the course of 30 vehicles. So it'd be 5 out of 30, and then you'd reduce it. You may remember this as empirical probability. Probably not. The other word you would probably see is experimental probability. Okay, so an example would be using a tack. You know how we use it on a bulletin board, one of those little tacks or a pin, and you toss it, see how many times the tack lands with its point up rather than on its side over the total number of tosses. Example 2, a recent survey of 1,010 adults in the U.S. showed that 202 of them smoke. Find the probability that a randomly selected adult in the U.S. is a smoker. So we could write this as P of smoker is there were 202 out of 1,010, which we need to divide that. Comes out to 0.2, which what percent is that? 20%. Seems kind of high. Maybe not. Yeah. Okay, example 3, your teacher recorded that you were absent from statistics class 4 times out of the last 38 days. Find the probability that you were absent on any given day. So we need to round that. So that rounds to 11% probability. Okay, law of large numbers. As a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. As a procedure is repeated, the relative frequency probability tends to approach the actual probability. So the more times you repeat the experiment, the more likely you're going to get the actual probability. So an example of that would be flipping a coin. So our probability is 0.5. So if we flip the coin 4 or 5 times, it's not going to be as close to half as it is if you repeated it 100 times or 1,000 times. So that's why we have computer simulations that can repeat the procedure as many times as you want. Okay, classical probability is the next one. If a procedure has n different simple events that are equally likely, and if event A can occur in different ways, then we are going to write the probability like this. Number of ways A occurs over number of different simple events. So this is our theoretical probability. What should happen? If all simple events are equally likely. So experimental probability is what happens. Classical or theoretical is what should happen. Calculations can become very complex, and the probability of each simple event must have an equal chance of occurring. So an example is probability of 2 with a balanced and fair die. So how many 2s are on a die? There's only 1. How many faces or how many numbers are there? 6. So there's 6 possible outcomes, 1 outcome with a 2. So this comes out to 0.66 repeating. So we write it as this. Find the probability that when a couple has 3 children, they will have exactly 2 boys. So probability of 2 boys, and they have 3 children. So we need to look back at our list. They're having 3 children, right? So it's this. How many outcomes have exactly 2 boys?
2.
Okay, so 3. Out of 8. It's 1, 2, 3 out of 8. Okay, and then we would write that as a decimal. What's 3/8? 38. Okay, find the probability that if you flip a coin 3 times, you will get a tails more than once. Okay, so we need to come up with our sample space. And then figure out how many times you get a tails more than once. So we're flipping it 3 times, sorry. So what are the outcomes that we could have? Here's our sample space. We could have all heads, all tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails. What else? Heads, heads, tails, 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 heads. One, two, three, four, five, six, seven, 8. 8 outcomes. Okay, so tails more than once. So tails would be greater than 1. So I'm going to write my probability of my event be tails greater than 1. So let's see, how many will you have tails more than once? Is it 4? Out of 8, which what would that probability be? Half, or 0.5, which is 50%. Okay, subjective probability is our next one. This one is estimated by using knowledge of the relevant circumstances. So an example would be meteorologists use their expert knowledge of weather conditions to determine the probability of rain tomorrow. Example 2 was probably you would get stuck in the next elevator you ride. So how many of y'all have ever gotten stuck in an elevator? Yeah. Has it been like more than once or just one time? Yeah, I've gotten stuck in an elevator once. So what's the probability? Where would you estimate this to be? Is it impossible? Is it possible? Is it likely? Almost certain or certain? What do y'all think? Where does it fall? I'd say possible. Yeah, I would agree with you. So it is possible, but not likely. So I'm going to just put the approximately 0.25 or less. Probabilities and outcomes that are not equally likely. So the probability that a Republican will win the next election is not 1/2. Why would it not be 1 out of 2? Yeah, because there's more than one. Yeah. And yeah, because it's not just Democrat, Republican, and not all, like, there's that independent factor in there. And what I wrote is there are more variables than just Democrat and Republican. Okay, the complement of an event. So remember how we put A as our probability? So we do P of A. So the complement is P of A bar. So complement means the opposite of it. All outcomes in which the event does not occur. In reality, more boys are born than girls. In a typical group, there were 205 newborn babies, and 105 of them were boys. If one baby is randomly selected, what's the probability that the baby is not a boy? So we would do probability of boy, but with a line over the top. Or we could put not a boy. Or really, doesn't that just equal probability of a girl? Right? If it's not a boy, then it'd have to be a girl. So our probability would be 100 out of 205. So if we round that 49, 0.49. Example 2, you're choosing marbles out of a bag that contains 6 red, 4 yellow, 5 green. If one marble is randomly chosen, what is the probability that you do not choose a yellow? So probability of yellow bar. So everything that's not a yellow. So how many are not yellow? 11. Out of how many total? 15. Which comes out to be 73. Okay, real quick, let's write probability of event A happening plus the probability of A not happening equals 1. That is a relationship between a complement and its probability of an event and its complement. Unlikely events. Unlikely events would be considered to have a small probability of 0.05 or less. Unusual events, extreme result, number of outcomes of a particular type is far below or far above the typical values. Example 1, when a fair coin is tossed 1,000 times, the result consists of exactly 500 heads. The probability of getting exactly 500 heads in 1,000 tosses is 0.0252. Is this result unlikely? Is 500 heads, unusually low or unusually high? What do y'all think? What's the probability of getting heads whenever you do 1,000 tosses? 500 out of 1,000.
Oh, sorry.
Oh, you're okay. But they're saying the probability of getting exactly is that. Because you'll have above or below, right? The probability of getting exactly that, 0.0252. For some reason, I changed this last year to 0.252. I'm not sure if there was a mistake right here. We're going to put this. So the theoretical probability is 50%. Is this result unlikely? No. I don't really like this question. I think there's a typo in here. So let's just keep on moving. All right, example 2. When a fair die is rolled 100 times, you roll a 6 24 times. The probability of rolling a 6 exactly 24 times out of 100 rolls is 0.016. Is this result unlikely? Is rolling a 6 24 times unusually low or unusually high? All right, so this would be the experimental. So we are going to write this as 24 probability of 6. And this is our experimental. Is 24 out of 100, which is 0.24. Yeah, I think this is a typo. There's an extra 0. So 0.16 is what we're going to do. That's another typo. So the theoretical probability, right? Cool. So our theoretical probability of getting a 6. We could actually find that. We shouldn't have just been given that. We would actually find that, which would be 1 out of 6, right? Because there's one side that's labeled with a 6 out of a total of 6 numbers, which that comes out to 0.16 repeating. So that's where that number came from. That's how I know it's a typo. So if we look at the difference between this, 0.1, I'm going to put this as a 7. That'd be 7. So is this probability unusually high? This is unusually high. Is it really though? We need to look at that. We're comparing it to the 0.05. So this is greater. So is it unlikely? Or is it unusually high? What do y'all think? It seems about right. It's pretty close. And it's not... It's not an extreme result. So I'm going to say not unusually high or low. It's right around it. All right, and we are out of time. So we will finish this tomorrow. I did already open up the assignment. So all we have left is odds. That'll be our next page.